Cool. All right. Well, thanks everyone for joining us. Again, my name is Chris Shaw. I'm with Vocal Name America. I'm the North American product specialist. So again, I cover all of Canada and all of the U.S. And with this is that I have been with the company for coming on 6 years here. With that is that I've been a Focal guy since 2001. My main background is car audio. I've got 30 years of car audio, and again, I migrated into the home stuff about 5-6 years ago. So, with that being said, is we will get started here. Let me just share my screen, and I'll ask you, Tyler. Can you see the Focal logo there?
I can.
Perfect. All right. So, we'll start here. Two brands, one group. Again, we are Focal Name America. And this really started back in about 10 years ago in 2011 when we at Focal actually acquired Name. The idea behind this is that we had two separate companies that really had common values. Obviously, Focal on the acoustic side or the analog side, with us, hand building a lot of our speakers, and then the electronic side or the Name side. Again, to run all our speakers, the idea behind this is that both these companies build 95+% of our products in-house. Again, we have all of our R&D and development done in-house. And the fact is that the idea is that we have the idea of no limitations was really on the mindset. So with that is that we created Focal Name, the Focal Name Group back in 2011. Move forward a few years to 2014, where the Focal Name Group was actually purchased by a private equity company called Nextamp Partners. With this is that we then created the Vervent Audio Group, and doing so is that not only did we develop the largest audio group in Europe, but what it did is it allowed us to actually invest capital into both Focal's and Name's R&D departments, and with that is that allowed us just to continuously develop new exciting technologies. So with this is that we have over 430 employees throughout the world, obviously myself as being one of those, and with that is that we have over 8,000 dealers worldwide. Kind of quick breakdown of each company. Again, on Focal side, we actually have 2 locations in France. We have our main headquarters, main offices, and main R&D department, all in Saint-Étienne, France. So to give you a reference is that we are roughly about an hour and 15-minute drive southwest of Lyon. Again, this is where we have all our speaker manufacturing, we have all of our R&D departments, all of our testing sites, everything is built there. Now, we also have a second location in Beaumont-Lancy. This is actually a cabinet factory that we purchased back in 2007. And with this is that we've ultimately took the factory over, retrofitted it for our cabinet, building our speaker cabinets, and actually kept all of the professional cabinet makers in that location. So the idea behind this is that not only were we able to increase our quantity of cabinetry, is that we are also able to increase and maintain our quality of our speaker cabinets that we build. With this is that we have 240 employees in the Saint-Étienne location. With that is that we actually have 35 of those employees are in our R&D department. 30 of them are acoustical engineers, and 5 of our employees actually have doctorates in acoustics. So with that being said is that when you do the percentages is that we are roughly sitting at about 15% of our factory employees actually sit within our R&D department. This is quite substantial for the simple fact that you have other companies that have upwards of maybe 3 to 5% of their employees in the R&D department. One fact that Patrick Shaughnessy, one of my colleagues, had mentioned is that Klipsch has 3 people in their R&D department. So again, we invest very heavily and into the R&D department within our company. With that, so we also have the 40 employees in our Beaumont-Lancy or in the cabinet factory. On the Name side, our Name headquarters is located in Salisbury, UK, as a geography point of reference is that we are roughly about 30 miles away from Stonehenge. So again, this is where the company was founded, and again, we sit on that same, within that same manufacturing plant. With this is that we actually have all of our name products developed and and built, except for 2 models within this location. We have over 160 employees in the Salisbury location, or in the name location in the UK. And with that is that we have over 70% of the products that are produced at name are exported outside of the UK. So let's start with, let's look at the Focal. So Focal, again, we are, this year we are turning 42 years old. Again, the company was created in 1979 by our founder, Jacques Mahal. The fact is that we are actually on the same plot of land that today where we were actually started 40 plus years ago. Within the company itself, again, we obviously hold numerous patents over the last 40 plus years, and we also held many awards. One of the ones that we're most proud of is that we actually are considered a French heritage company. And what this means is that with this is that we are actually now recognized by the French government as a heritage company. So this puts us in the same company as groups like the PSA Group, as an example. This is the company that owns Renault and Peugeot, as well as other companies like Louis Vuitton, as an example. So the idea is that we have actually become very iconic of the French French culture within France. So kind of a brief timeline of our 40 plus years of history is that starting on the left-hand side, there's our founder in 1979, again, started the company. The idea behind this is that Jacques Mahal was a acoustical engineer, and the idea was that he was working for another company, and he left that to start his own for the simple fact that he wanted to build products with no limitations, and ultimately he wanted to be the best of the best of the best. By 1982, he released his first loudspeaker, the DB13. With this is this is where we started to receive our first set of awards. 1989, we developed our car audio program. Again, obviously, which has become very, very, very strong in around the world, and especially in the U.S. and Canada markets. As we move forward, 1996 was the release of our first Grande Utopia. 2002 was a big year. It's actually two key features. One is that we launched the Pro Audio department, and it was the first year that we started using beryllium in our products. Fast forward to 2011, again, the acquisition of Name. 2013, again, we developed and released new cone technology called Flax, which we'll talk about shortly. As we move forward, 2016 is when we got into the high-end headphone category, and since then have dominated right from 2016 to today. 2018, again, with this is that we developed a new cone technology called Utopia M. Again, a new cone profile that was placed into our car audio products, and now we're starting to see migrate into our home products. 2019 was, again, a big year for us. It was our 40th anniversary. Now, with that is that almost every year that we release anywhere between 10 to 20 new products a year. Obviously, 2020 was some crazy situations with the COVID, and so with that is that we actually held a lot of our products off till 2021, and in turn actually basically expanded our R&D department in France. So as I mentioned, is that we are a worldwide company, and with that is that we have received numerous awards from around the world. With that is that we actually just received our latest award just as of a few weeks ago with some of our brand new headphones and new CI products that we just launched over the last 90 days or so. So this is our collection, and again, as you can see, we're quite diverse. The fact is that we are actually one of 2 companies in the world that is actually fully integrated in the conception of music, which means that we are there when the artist is recording the music. We are there when the engineers are touching up the music and quote unquote engineering the music. But the fact is that we are also in every other location, whether it be in our home, our vehicles, or in our personal audio. And what's very special about this is that on our pro side is that we're in over 5,000 professional studios in the US alone. So the fact is that when you are ultimately replaying your music, whether it be in your home, your car, or your personal audio, is that because the music was engineered and recorded on Focal, is that you ultimately are reproducing or listening to the music just as the artist intended it to sound like. So again, this is very special. With this is again, we have some very great partners on the professional side. We have some very iconic artists like Alicia Keys, Stevie Wonder, Steve Aoki, and also our newest partner is David Guetta, that is actually partnered with us on the Focal side. So again, some very high-end artists that are making some very great music. Again, using Focal products. So Kone Technologies. No, this is really the core of Focal. The fact is that, as you can see, is that we have all vertical channels listed on the page, whether it be our home classic product, our custom integration, car audio, professional audio, and our headphones and new media product. The fact is that we at Focal, the ultimate core is our Kone Technologies, and every time that we talk about Focal, we always talk about Kone Technologies because it is really what sets us apart from our clientele or from our competition. So the truth is that everything is listed here because we do have individual teams that work on the individual categories. But the fact is that we actually share technologies where we can have a technology from our home classic that goes into car audio. We can have car audio that technologies that is developed in car, but is actually then migrated into things like headphones and custom integration. And so with this is that our teams are separate, but yet still always working together for the greater good. So we start with how we develop our cones. And the fact is everything that we have is based off this, the MRD ratio. And the MRD ratio stands for mass, rigidity, and damping. And the truth is that when our founder Jacques Mahal started the company, is that he came up with this ratio very quickly. The fact that with this is that you could never create this ratio with a single material. And obviously, some of the more popular materials out there are things like polypropylene and paper, as an example. So the fact is that everything we do is based around this ratio. So when we break it down quick, just into the three subcategories: mid-range woofer and subwoofer. Is that, as you can see, as the average bandwidth starts to decrease or the frequency range lowers, is that the excursion increases. And so this is really important when we start to figure out our ratio. So starting on the left, we have our mid-range. And so again, we have a cone material that we're asking to oscillate upwards of 2,500, 3,000 times a second. So mass is quite critical, and with this, so the mass is dropped quite significantly. Now again, because of the lower excursions, is that we don't need as much rigidity. But when we talk dampening, is again, this is where we get a lot of our definition, our detail. It's also where we're most sensitive in our human hearing range. And so with this is that we add a lot of emphasis into the dampening side. And so, again, we don't want to add our own flavor into the output of the speaker. Things like ringing or muddiness and so on like that. So again, dampening is quite crucial. As we start to move down the range, the subwoofer mid bass woofers are kind of a one third ratio. And then when we get down into the subwoofers, is that we realize is that to develop low end frequencies, we need a greater amount of mass to compensate for the large excursions, upwards of 20 or 25 millimeters of excursion. Is that we need that rigidity so that the cone doesn't distort under atmospheric pressure. And because of the limited bandwidth, is that dampening is considerably less important as the other two factors. And so with this is that these ratios always change based on their applications. And so this is very crucial to get that best sounding cone. Now, the truth is that we actually do things quite different at Focal from most of our competitors. The truth is that a lot of our competitors, when they're developing a new speaker, is they will go to, quote unquote speaker mart, and they'll go buy 10,000 tweeters, 10,000 mid ranges, and 10,000 mid basses. They'll come back to their manufacturing facility. They will then, produce or design a cabinet around these speakers. And then from there, what they will do is they will then build a crossover to try and make all three of these drivers work as one entity. Well, we at Focal actually do everything backwards. The truth is that we actually start with the cabinet, and it starts in our design team, and they get, they do the fit and finish, they do the shapes. And obviously they're quite experienced with this. And then once the cabinet is actually finalized and approved, is then the cabinet will actually go to our R&D department. And so with this is that we will then either find a driver that works optimally in that cabinet, or we will then turn back to the MRD ratios here and develop a driver that works in that cabinet. The fact is that even though that we may have two drivers that look identical, maybe between a 6.5 in our Utopia products versus a 6.5 in a Sopra, is that they can be actually completely different drivers, completely different specifications. So with this is that once we have figured out and found or built the optimum driver for that cabinet location, is that we can then build our crossover networks. And the fact is that we can now build simpler crossovers, which makes them more efficient because we're actually not having to compensate for any inefficiencies between the driver and the cabinet in the crossover network itself. So you will see that most of our speakers are all 90 dB plus of sensitivity because of the simplified crossovers. Now, to create the MRD ratio is that we know that we cannot use a single material. And so with this is that we have developed what we call sandwich cone technology. So which means is that we, on all of our drive unit or speaker cones, is that we actually have a core sandwiched between a top and a bottom layer. And so within our lineup, we have our three main categories. We have our W composite sandwich cone, we have our flax sandwich cone, and our brand new cone technology called slate fiber, which again is a sandwich cone technology. So I cannot give you any of the details without having my scientific bar graph. So here's my bar graph. So this is actually a index of rigidity, or basically a strength. So with everything being equal, of how many newtons per millimeter each material is measured in. So if we start on the far left-hand side, we start with our polypropylene. Again, this is 42 newtons per millimeter. The fact is that roughly 80 to 85% of our competitors sit in this column, again, using a single material or the polypropylene material. As we move from left to right, again, we have our impregnated Kevlar fiber, paper, and then we start with slate fiber. Now, slate fiber is actually our entry-level cone material, but what you can see here is that we actually have roughly 30 times the rigidity with our slate fiber cone technology. As we move up into our flax cone technology at 1505, we're right around about 40 times the rigidity. And then as we move into our W sandwich cone, is that we are actually sitting at 180 times the rigidity of that polypropylene cone. So what exactly are these cone technologies? Well, let's start with the W composite sandwich cone. Now, this is our flagship cone material. We've actually had this cone for over 20 years, and it was actually developed in the early to mid 90s. And so we'll start with our core. Our core is actually a Rohacell foam. Now, this is actually a declassified military technology that was utilized for dampening high-end fighter aircraft. And so what it is a very lightweight foam that is actually comprised of roughly 85% air. So with that being said, is that obviously with that ratio of air is that it's very, very light, but it also is a very good dampener because we know that air is a great dampener. And so we start with the Rohacell foam core. Now, with this is that we can change the dampening of this speaker cone based on the thicknesses of the foam core itself. So again, if we need more dampening, we can make it thicker. If we need less dampening, we can make it thinner. And with that is that once we get that dampening property set, is that we then sandwich that foam core within layers of glass or fiberglass, basically. And so with this is that again we can change the rigidity by how many layers of glass that we place on the front and the back of this sandwich cone technology. And so with controlling those other two ratios is that we can now adjust the weight. So this becomes a fully customizable cone. With this is that not only can we change the MRD ratios, is that we can also adjust for the cone size as well as also the cone profile. Now, with that is that this cone is actually 100% handmade, which means that we actually have staff within our manufacturing facilities that manually stretch the glass fibers onto the mold, manually shape the foam core. And with that is that once that is all done, we place it into the mold. We then place it in the oven, and on average, we only build 6 of these cones every 10 minutes based on a 6.5-inch driver. So with that is that there is a lot of attention to detail to this cone. Once the cone itself is being baked, has been cut, is that we measure every single cone. And again, that is true with every cone that we build, not just this one. And the fact is that our tolerances have to be within 1/10 of 1%. So, and that means on weight and thicknesses and cone profiles. If it does not meet those specifications, now there's no point with us moving forward with this cone because it will just be wrong from that point forward. So if it is wrong, it is then recycled and we start over again. So with that, because of the attention to detail and the limited quantities that we can build, this is a very expensive cone, and this is why we utilize it in a lot of our high-end products. So part of our R&D department is that we actually have computer simulations. The idea is that because we develop our cones based on their requirements, is that we do use this computer. And if without the computer, is that we would have to build on average roughly about 10,000 cones to find the one cone that we need for its application. So with this is that we actually took screenshots and screen recordings of the actual machine itself. So why is this important? Well, we'll start with 2 cones. We'll start with the cone on the left, which is our polypropylene cone. Again, this is where a lot of our competitors tend to sit. And on the right-hand side is our W sandwich cone. Now, we're going to show you a simulation at 2500 hertz. And we picked this for the simple fact that this is actually the most common crossover point between a mid-range and a tweeter. Now, the idea of this is that when we build a single cabinet is that we put different drivers into the cabinet. We put a mid-bass driver, a mid-range driver, and a tweeter in there, and we actually try to make them all work as one. But there has been times where we have listened to a speaker and thought, man, this just isn't working as a single unit. I can hear the tweeters working separately from the mid-range or the mid-bass. And the fact is that not many people realize why. Well, when I show you the polypropylene cone, and again, these are real live measurements, is that you can see as the voice coil moves in its up and down pistonic action, is that parts of the cone actually start to become out of phase with the voice coil. And the major issue with this is that this is a mid-range that we are trying to phase align with a tweeter. And this becomes a real problem trying to make these work as one when the mid-range itself is not even in phase with itself. And so it's almost nearly impossible to phase align a tweeter properly with this mid-range. So when we show you the W sandwich cone, again, as you can see that the entire cone itself stays within phase of the voice coil. And so with this, it means that it allows us now to phase align a mid-bass driver or a tweeter quite easily with this. And again, allowing us to then build that simplistic crossover. So our next cone technology is our flax sandwich cone. And honestly, this is probably the cone technology that we get the most questions about. As the first question is, what is it? Well, the truth is it is exactly what it sounds like. It is actually a byproduct of the flaxseed. And so once the flaxseed is harvested, we actually take the stem of the plant and we actually will then weave it into sheets called linen. So the first question is, why flax? Well, the fact is that in the late 2000s, early 2010s, is that we started to look for a new cone material, and the idea is that we wanted maybe to look at something on the organic side of materials. And so with this is that we kind of started hunting the world for different technologies. We played around with a lot of different materials. We actually were playing around with like woven palm leaves as an example, and with that is that we actually stumbled across flax. And again, flax is being utilized for thousands of years by the human race. And so, when we started looking at flax, is it really fit our build on the mass side? Again, going back to the MRD ratio, is that the flax stems or the flax fibers themselves are actually hollow. And the advantage of this is that not only is it light because it's hollow, but also anything that's hollow has air in it, which means that we also get some advantage of dampening. When we looked at on the rigidity side of it, is that we actually looked on a molecular structure, is that flax actually has a very similar molecular structure to Kevlar. And again, we all know that Kevlar is very light, but yet it's still extremely strong. And the last one was dampening, is that because it is an organic material, it is actually comprised of 80% cellulose. And as we all know, that cellulose is, well, it's paper, and we know that paper is a really good dampener. And so flax really fit that build for that MRD ratio, which again was great. Now with our flax is that we started to look where to source the flax. And again, Canada and US are some of the largest exporters in the world of flax. But when we really looked for the principles that we needed, is we actually found it in our backyard. We actually found it in northern France, up in Flanders, Picardy, and Normandy. And so now the bonus of this is that we have a high performing material that doesn't cost us a lot of money for transportation costs on the raw materials. So with this is that we were able to produce a very high performing speaker for a much less cost because of where we were able to source it. So as I mentioned, is that flax is also a sandwich cone. And so with that is that we can change the parameters. And so as we need to change the ratios in this case here, is that if we look at the woofer, is that we have basically a 2.5 to 1 ratio when we're talking the ratio between the inner core density versus the outer rigidity glass fibers. But when we actually get to a mid-range, again, as we told you before, is that we require a lot more dampening versus rigidity and mass. And so with that is that we actually have a 3 to 1 ratio based on our core to the front and back ratios. So again, this is again what we call that on-demand construction, where we can basically build the driver for its application. So moving on to our last cone technology, and actually our newest cone technology, is our slate fiber cone. I will start with telling you first and foremost that there is no slate in this cone. It is actually named after the color of the cone itself. So what is it exactly? Well, before I get to that, we'll give you a little bit of history. As I mentioned, is that it is our newest cone technology. With all of our cone technologies, is that we have nearly, in this case here, we have over 4 years of R&D, and that seems to be about the average it takes us to develop a new cone technology. The idea behind this is that we wanted a new cone technology to replace what we call polyglass. This is one of our oldest cone technologies that we have, and yet still utilized today. And the idea with this is that we wanted something that we could mass produce, because knowing that this was going into our entry level products, is that we wanted a high-end cone technology that had the ability to produce a lot of cones. So as we started with our W sandwich cone, where on average we're building 6 cones every 10 minutes, to flax cone technology, where we're roughly building about 20 cones every 10 minutes, to where slate fiber is where we're building over 1,000 cones a day, just again to keep the cost down. So what is the slate fiber cone? Well, it is actually a recycled, non-woven carbon fiber encapsulated in a thermoplastic polymer. Now, let's break that down. So we'll start with the non-woven orientated carbon fibers. With it is that we obviously know that carbon fiber is very strong. But there is a downside of woven carbon fiber is that it actually has a resonant frequency, and it's right around between about 23 and 2500 hertz. And so with this is that we actually unweave the carbon fiber or use unwoven carbon fiber to remove that resonant frequencies. But now with that is that as we unweave carbon fiber, we lose that rigidity. So with this is that we have actually patented a process where we actually orientate or basically place all the carbon fiber strands into one direction. And by us doing this is that we regain the rigidity that was lost. So once that has been done is that we then sandwich or encapsulate this non-woven orientated carbon fiber core into a thermoplastic polymer. And so with this, again, this is a sandwich cone technology where, again, we can change the inner core of the cone itself for either better rigidity or even so basically better strength. And then again, we can change the thicknesses of the thermoplastic polymer to increase dampening, and again, adjusting those two based on weight. So with this is that with the new cone technology is that we also have a new process. And the fact is it actually is the first robot that we have ever brought into our factory in over 40 years. And so with this is that we still build all of this in-house, but again, it allows us to be semi-automated, just like so that there's still human hands on this on it. But again, we're able to build upwards of 1,000 cones a day. So as you can see, the process of pressing the material, cutting the material is all automated. And with this at the end of the line on the far right-hand side is that we still have human people basically assembling the cones, so attaching the voice coils, the surrounds, and placing them into the speaker baskets and so on. So with this, again, with everything that we do, we're always looking to move forward. So as you can see, and unfortunately, when the graph was created, we hadn't had a name for it. So we called it New Polyglass. But we started with the old Polyglass on the chart on the left. And as you can see, is that the new Polyglass or the new slate fiber cone is much closer to our W sandwich and our F or our flex sandwich cone for, again, performance. So moving on to our tweeter dome technologies. Again, we are obviously known for our beryllium tweeters, but we're also known for our inverted dome tweeters. And so with that is that we want to explain why we use inverted domes versus the classic dome. So in this case here, we're going to compare a classic dome versus the inverted dome. Again, both of them being 1 inch. So again, all things being equal. So why an inverted dome? Well, the first point is that we run on the same principle as a mid-range woofer or subwoofer, is that when we're talking a voice coil, is that when you have a standard classic dome, a 1 inch classic dome, is the fact is that you must put a 1 inch voice coil for the simple fact that the only place for you to adhere a voice coil to this dome is on the very outside circumference of the dome itself. When we go back to the same principle as a mid-range woofer or subwoofer is that we can actually now make the voice coil smaller than the tweeter itself. And the advantage of this is that anytime that we make something smaller is that we also make it lighter. And again, this is very crucial, especially when we're asking this drive unit to oscillate between 10 and 20,000 times a second. Weight is extremely crucial. So that is one of the reasons that we do this. Secondly is that when we have a smaller voice coil is that we can place it into the middle of the dome. The advantage of this is that we can now take the energy from the voice coil itself and transfer it basically evenly through the dome itself, where when we compare that to a classic dome is that the energy itself starts at the bottom of the dome, and when we start to get to the very top or the pinnacle of the dome is that we don't have the ability to control that top part of the dome, and it will tend to start to ripple or collapse or even become out of phase with itself. And again, that can come off as somewhat being kind of raspy in some cases. The last feature of this is mechanical coupling. Is that obviously anytime that we mount something end to end is that is the smallest surface area for you to adhere a voice coil to a dome. where, again, when we're talking an inverted dome, we create a T intersection, again, allowing us to, again, have better coupling. The last advantage of having the inverted dome is, again, directivity. On a standard classic dome is that, yes, this tweeter is designed to radiate 360 degrees around its circumference, but also now multiplied by 180 degrees. And in a lot of cases, a lot of our competitors will use things like waveguides to control or try to focus this energy coming off that tweeter. Where on an inverted dome, yes, we still radiate 360 degrees around its circumference, but that 180 degrees is now actually moved back down to 110 degrees. And the advantage of this is that we have what we call lesser directivity, which allows us to have better off access to listening, or ultimately increases our quote unquote sweet spot, where you maybe have a 2x2 spot on the couch, which is your great listening area, where with an inverted dome tweeter is that you can have multiple locations on your seating area or on your couch, and again still have that staging, the depth, the focus of that performance, whether it be multimedia or 2-channel listening. So again, with it, again, we feel that this is a much superior tweeter. Now, when we talk in materials within the tweeters, again, everything is, there's nothing that is overlooked. So we'll start with what we're most commonly known for is our beryllium inverted dome tweeters. So taking you back to grade 7 science class is that beryllium actually has a atomic number of 4, so it's number 4 on our periodical table. The fact is, it is actually the lightest metal known to man. It is also the first solid on our periodical table, with hydrogen, helium, and lithium being numbers 1, 2, and 3. And so again, going back to grade 7 science class, we all know that the lower the atomic number, the lighter the material itself is. And so again, that goes back to our MRD ratio. Now, when we look at some of the other attributes of beryllium, is that we know that it is extremely rigid. It is actually the other material that will scratch glass, obviously diamond being the most commonly known one, but also has a very high internal dampening. And again, this is why it is utilized on things like fighter aircraft, and utilized in like satellites and space probes and so on like that, because of the very high internal dampening. One of the other attributes is that it has great thermal conductivity, which means that we can use our domes as a radiator to remove heat from the voice coil of the tweeter itself. And ultimately, when it comes down to it, it has the best stiffness to weight ratio of any materials out there. Now, there is a downside of this, is that it is 50 times the price of gold. So watching the news this morning, gold is hovering right around about $1,800 an ounce. So you can do the math quite quickly of the cost of beryllium. And again, this is why we only utilize it in our flagship products. Now, with that being said, is that there is actually 4 locations in the world where beryllium has been mined. South America, Madagascar, in eastern Russia, and Utah. The fact is that every mine has actually been closed now except for Utah, which is really quite lucky for us, because it is actually the mine that we started working with in the late 90s and early 2000s to develop the beryllium. Now, why is this important? Well, it actually comes to my favorite saying in the presentation. The definition of sound is directly linked to acceleration, and acceleration is inversely proportional to the mass. So ultimately, is that the definition of sound is directly linked to the mass. So with that is that, as I mentioned, us working with the mine in Utah, is that we were able to patent and develop a process so that we could actually get the beryllium down to 25 microns thick. And with this is that we at Focal actually hold the patent for any beryllium 100 microns or less. So this is really important for the simple fact that a lot of our competitors have now caught on to why we use beryllium. And there is a lot of companies out there that are microfusing beryllium particles to another material. They're mixing beryllium with other materials like copper, as an example, which is quite popular. But there is a few people out there that are starting to use the pure beryllium dome tweeters. But the difference being is, again, we hold the patent from 100 microns or less, which means that our competitors have to be at least 100 microns thick. At that point in time, even if we are comparing apples to apples, is that we are 1/4 the weight of our competitors. And again, the definition of sound is directly linked to mass. So with that is that, again, we have a major advantage of this. So one of the other materials that we talked about, that we already talked about, and our competitors is using, is diamond. And again, as we mentioned, diamond is also extremely rigid. And with that is that obviously B&W has put a lot of marketing around their diamond tweeters. And again, diamond is very strong, which is again one of parts of the MRD ratio that we've showed you. Now, but there's the downside of diamond, is that, as you can see, is diamond is very heavy. In fact, it's actually 5 times heavier than beryllium. And so, as I just mentioned, is mass is very crucial, especially when we're talking something that needs to oscillate 10, 15, 20,000 cycles a second. So with this, as we compare our aluminum magnesium, which again is a material that we use, sits at 0.0483, beryllium at half that weight at 0.0182, and diamond at 0.0989. Now, again, you will see B&W tell everyone their tweeters are very rigid. They're extremely rigid. We use diamonds. They're very tough. But what they don't talk about is that they're also very heavy. So when we do our comparisons here, is that we have our positive soft dome. Again, this utilizes a very low mass material. This is a good thing, but unfortunately, there's not a lot of rigidity in that, and of course, that's a negative to that. When we talk about positive diamond domes, is that it has very high rigidity, which is great, but unfortunately, that material is very high in mass as well, which is a negative. And then we compare that to the inverted beryllium dome, which again has the low mass material, but yet still maintains the high rigidity. So again, back to our computer-aided technology here. Again, comparing, our pure silk dome tweeter. So as I mentioned, is again, when you have material that's that doesn't have a lot of rigidity to it and is a positive dome in that energy, as you can see that the tweeter dome itself starts to ripple or starts to lose or becomes out of phase with itself. And again, as I mentioned, at 16,000 hertz, as we're showing you here, is that this comes off as distortion, or even at the very best is it comes off almost raspy. And again, we don't want that. So when we compare that to the beryllium inverted dome tweeter here, is that you can see that the dome itself stays structurally intact, and with this is it allows us to have a very smooth response all the way up through the audible frequency spectrum. So again, having a very smooth response all the way to the point where we can no longer hear it. So another technology that we use in more of our midline products is our aluminum magnesium inverted dome tweeter. Now, with this is that we know that aluminum is very rigid. Obviously, we see this utilized in hundreds and thousands and millions of different products. But as we all know, is that aluminum tends to potentially have a bit of a flavor in it, possibly a little bit of ringing to it. And so with this is that we actually add in a 15% magnesium mix to this. And by us doing this, is it adds additional dampening. Again, getting rid of that ringing sound of the aluminum tweeter, and adding rigidity, but not adding weight. So again, even our tweeters fit in that MRD ratio. Now with this is that we also have some of our top-down technology, is that we now pair the aluminum magnesium inverted dome tweeter with a Poron surround. Now, if you notice is that the Poron surround is actually underneath the dome itself. And so with all of our tweeters is that we tend to use a Poron surround underneath the dome. And the reason for this is that as that pistonic energy comes from the voice coil itself, is that on a traditional tweeter with a traditional surround, is that energy is then pushed into the surround, ultimately causing heat. Where in our case is that because the surround is below the dome itself, is that that pistonic energy coming in a front to back motion of the voice coil itself is actually transferred into the dome and is actually output as sound rather than heat. And with that is it makes our tweeters anywhere between 1 to 2 dB more efficient. So again, in a lot of cases, you will see that we will change the impedance of the tweeter to correct for that that added efficiency of the tweeter itself. So again, with this is I have my bar graph, again showing back to index of rigidity. Again, we'll start on the far left-hand side. We'll start with the soft dome at 50 newtons per millimeter. Again, all things being equal. Aluminum sitting at 385, almost 8 times the rigidity of that soft dome. Aluminum magnesium at over 11 times. And our beryllium that sits over 100 times the rigidity of that soft dome tweeter. All right, any questions up to this point? Wonderful, we'll move on. All right, so let's start with our home classic products. So we will start with Kanta. With this, I will say that we do have 2 model numbers or 2 series above this. But with that is that we will start with Kanta, because again, from my understanding, this is where you guys are kind of starting at with this lineup, and then we'll go from there. All right, so we will start with Kanta. Again, Kanta is our midline product. This product is made in France. We have 3 main models. We have our Kanta number 3, Kanta number 2, Kanta number 1. Within these, we also add in a Kanta center and a Kanta stand. Now, the Kanta stand can be utilized for both the center channel as well as the Kanta number 1 bookshelves. The code technologies that we are utilizing within this series, we are using the beryllium inverted dome tweeter paired with the flax sandwich cone technology. So with this is that we also have a very unique tweeter built for Kanta. We have our newly designed IAL3 tweeter. So with this is it stands for an infinite acoustic loading tweeter. So ultimately, as I mentioned before, is that we always have trickle-down technology, which means that we have actually taken technology from the IAL2 tweeter in our Utopia series, which is our flagship product, and the IHL, or infinite horn loading tweeter from Sopra, and have basically combined these 2 feature sets into developing the new IAL3. Now, with this is that we have created this sealed unit, but we again have developed the ability to place almost foam into the sides of the beryllium tweeter. By doing this, it almost creates an aperiodic membrane. So again, allows for us to have a very large open sound with this tweeter, and again have placed basically a foam within the back of the dome itself, again allowing us to cancel that first wave coming off the dome of the tweeter. Now with this is that we also have some other trickle-down technologies, and the first one is in our mid-range drivers, and this is called a tuned mass dampener, or TMD. And the fact is that as we have continued to develop our drivers, is that we are looking for the ultimate perfection. And one of the places that over the last few years that we noticed is that we were receiving a bit of distortion off of the suspension or off the surround itself. And the fact is that we were seeing this distortion between the frequency ranges of 800 hertz and 3500 hertz. And again, this is where we are most sensitive. And so what we have created is that we have actually created these small rubber ridges that go around the surround itself. And by us doing this is, as you can see, that we can control the surround. And by doing this is that we can eliminate upwards of 50% of that distortion coming off the surround itself. So again, a very neat technology and very simple technology to help us alleviate an issue that, again, most people would never know is even there. So one of the other feature sets that we have built into the Kanta series is our NIC magnetic circuit. And again, this stands for the neutral inductance circuit. So with this is that as a voice coil moves in and out of the magnetic gap, is that it will change the measurements of the voice coil itself. This will change the electrical impedance as well as the electrical inductance. And with this is that as these change, an amplifier must change as well to try and compensate to control the speaker. So the idea with this is that with this NIC technology is that if we can try and keep the inductance and the impedance much closer to its reference point is that an amplifier has a much easier time controlling that drive unit, and the advantage of this, or the result of this, is that we can ultimately lower distortion coming from the amplifier and the speaker combination. So as you can see, in red is without the NIC circuit, and in blue is with the NIC circuit. So again, considerable change with and without the circuitry. So now with this is that with Canta came a new process, new thought process, is that we build obviously most of our products out of MDF. The series above this is our Soper cabinet. It is extremely structurally rigid, upwards of almost 3 inches thick on the front cabinet to try and control any kind of or to try and maintain rigidity within the cabinet. So when we built Canta, is that we wanted to have a lot, if not better, properties than Sopra, but in a smaller footprint. And so with this is that we developed a new high density polymer for the front face. So with this is it not only gave us smoother edges on the corners and around the around the tweeter itself, is that we increased the density by over 70% over MDF. We increased rigidity by 15% over MDF, and dampening by 25% over MDF. And we did this all while maintaining a 35% smaller or thinner profile than the series above it. So again, had higher performance in a smaller footprint onto the floor. So within that front face as well, is that we've also built in a passive time alignment or focus time. And by us setting the tweeter itself back and now time aligning the tweeter with the mid-range and the mid-bass drivers themselves directly through the cabinet, allowed us to now have better coherent alignment between these 3 drivers. We also built in a few cool features into the cabinet itself, is that we have also built in a variable radius. Again, this is not necessarily visible to the human eye because it is somewhat slight, but by us being able to do this, is that, again, not only allowed us to have that smoother finish on the front, but it also allowed us to control any kind of standing waves within the cabinet itself. Now, talking about the cabinet, as we mentioned, again, as you can see here, on a Soper piece, is that the cabinet itself is extremely thick. And again, that's the same that goes with our Utopia product. But again, this unfortunately does take a little bit larger footprint on the floor. So with this is that we actually patented a new technology where we have actually created the cabinets in Canta out of molded plywood. By us being able to do this is that we were able to increase the rigidity while still maintaining that smaller footprint of the cabinet itself. Moving on to the vents, is that we actually have basically a tri-tuned enclosure. What this means that we have 2 vents, one on the front that is tuned more for like a mid-bass or higher a harder hitting impact of that solid bass, and then a vent on the back that is tuned much lower. And this again allows us to develop the low end frequencies with the Canta. With this is that we have also paired the cabinet itself with a die-cast foot system, and we then paired that with the same spike systems that we are using on Soper. And the idea behind this is, again, trying to eliminate or lower any kind of resonances or energy that's coming from the floor itself into the cabinet. And by us doing this, or by us removing this energy coming from the floor into the cabinet, is it tends to make our mid basses a lot more accurate and a lot less muddy. So last but not least, finishing off the cabinet, is that the cabinet itself is finished with a glass top, and again we do have the magnetic front grills. Now with this is that you can utilize it with or without the grills. One of the big changes that we have made in the last few years is that we have now actually tuned all of our speakers or all of our tweeters with the grill itself now in place. In the past is that we have always asked to remove the grill, And with that is that without removing the grill, it was also always a little bit dull on the higher frequencies. So the problem with that is that with the grill removed and people in tape measures, is that we were seeing a lot of tweeters coming back to us with the imprint of a tape measure pushed through the dome itself. So with that is that we changed the tuning of the tweeter. We actually made it brighter so that when we placed the grill on there for protection of the tweeter, is that we had a very fluent tweeter output. So again, this is very crucial that the tweeter grills stay on these speakers moving forward. So within the Kanta finishes, again, we have five finishes in total. We have our Carrera White, which is a white high gloss face with a white high gloss cabinet. We have Black Lacquer, which is a gloss black face with a gloss black cabinet. We have our Walnut High Gloss, which is again a black high gloss face with a gloss walnut cabinet. And then we have our two matte finishes, our ivory finish and our dark gray. So the face and the cabinets are a matte finish on these two units. And these finishes are available in all of the models themselves, the Kanta number 3, Kanta number 2, Kanta number 1, and Kanta Center. Now, to kind of break down the drivers themselves and the drive units is, so we'll start with our Kanta number 3. So again, this utilizes the 27 millimeter IAL3 beryllium inverted dome tweeter. This is paired with a 6.5-inch mid-range with the TMD and the NIC circuit, and two 8-inch mid-bass drivers. Now, within this series, again, we utilize the same tweeter across all models. We use the same mid-range across all models. And what mainly changes is obviously cabinet size and mid-bass drivers. So Kanta number 3 is, again, tweeter, mid-range with two 8-inch mid-bass drivers. Kanta number 2, again, a beryllium tweeter, 6.5-inch mid-range with two 6.5-inch mid-bass drivers. And our Kanta number 1 is our standard two-way bookshelf, and our Kanta Center is utilizing the same tweeter as the last three models with two 6.5-inch mid-range drivers. Now, things that you should look at here is sensitivity. Is that if you notice that almost all of our speakers, except for the bookshelf, is all above 90 dB, and the recommended amplifier power is that even a Kanta number 3, which is our large three-way floor standing speakers, two 8-inch drivers, 6.5-inch mid-range, and the beryllium tweeter runs efficiently as little as 40 watts a channel. Moving on to our ARIA 900. Again, this is our more traditional floor standing speaker set. So within this series, again, we are utilizing the flax cone technology paired with the aluminum magnesium inverted dome tweeter, or the TNF tweeter. Within this series, again, we have multiple models. We have our ARIA 948, ARIA 936, ARIA 926, and ARIA 906. Again, like the Kanta, the major differences is the mid-range, mid-bass drivers. As you can see, the ARIA 948 includes two 8-inch mid-bass drivers. ARIA 936 includes three 6.5-inch mid-bass drivers. ARIA 926, two 6.5-inch mid-bass drivers, and our ARIA 906 is our traditional bookshelf or two-way bookshelf with a beryllium inverted dome tweeter, or sorry, aluminum magnesium inverted dome tweeter with the flax 6.5-inch mid-range. Within the series as well is that we also have our ARIA CC900 center channel, ARIA SR900 surround, and the ARIA S900 stand, which again can be utilized for the ARIA CC900 and the ARIA 906 bookshelf. So within the ARIA series, again, we do have a dual vented tri-tuned enclosure. Again, the front vent is for that heavy hitting mid-bass attack, and the down-firing vent is for that low-end frequency development. The entire cabinet itself is placed onto a cast base, again, utilizing either spikes or rubber bumpers. Again, the idea behind this is for us to isolate the cabinet away from the floor so that, again, that low end or that mid-end or mid-bass energy is not drawn back into the cabinet, muddying up that hard-hitting impact. As I mentioned, is that we are utilizing the aluminum magnesium inverted dome tweeter. This is the TNF tweeter. This is the latest generation of tweeter. The idea behind this is that as we develop new tweeters, we always make improvements. In this case here, we have a much smoother response in that 2,000 to 4,000 hertz range. ARIA finishes include two finishes. We have our black high gloss finish and our Noyer, which again is a walnut veneer finish. And again, just going through some of the specifications here. Again, we're pairing the 25 millimeter TNF aluminum magnesium inverted dome tweeter with the Flax 6.5-inch mid-range in all models. And as I mentioned, the RA948 two 8-inch mid-bass drivers versus RA936 three 6.5s, RA926 two 6.5s, and the RA906 are bookshelf, two-way bookshelf. Again, the RS CC900 includes two 6.5-inch mid-range paired with the TNF 25 millimeter aluminum magnesium inverted dome tweeter, and our ARIA SR900 includes two 5-inch mid-bass mid-range drivers paired with two TNF 25 millimeter aluminum magnesium inverted dome tweeters, and this is also a bipole surround speaker. Again, as you can notice, is that again sensitivity all hovers right around 90 dB, and power consumption on all of these units starts in that 40 to 50 watts and all the way up to 300 to 400 watts per channel. Moving on to our Core 800. This is again our newest cone technology, our newest speaker line. Like the previous two models, ARIA and Canta, is that this is also made in France, which means that all of our floor standing products are made in France. So we will start with our model numbers. We have our Core 826D, our Core 826, Core 816, and Core 806. Now, with this is, again, like the previous two models, major differences are mid-bass drivers between the 826, 816, and 806. The major change between with the 826D and then 826 is that we have a Dolby-enabled Atmos speaker on the top of the Core 826D, which again we'll get into a little bit more detail. With rounding out the series itself is that we have the Core Center, Core Surround, and the Core Stand. Again, can be utilized for the Core 806 or the Core Center channel. Now, the idea behind this is that when we launched this product in late 2019, early 2020, is that we wanted to build something to get new clientele into the Focal high fidelity. So the idea behind this is that the Core 800 is the gateway to the Focal high fidelity world. The idea behind this is that we wanted a product that was had a very modern design, had a very high performance, had a made in France stigma to it, but yet was very cost effective. And with this is that this range starts in at $990 for a pair of 806s and top out at $2,600 for the flagship Core 826Ds. So with this is that we've built in again the modern design. We also built in a passive time alignment. So we have actually built in a 15-degree time alignment into the cabinet, again, allowing us to set the tweeter back so it time aligns with the mid-range and the mid-bass drivers. And with this is that we utilize, again, our new slate fiber cone technology that we showed you previously. Again, as we're showing you here. Again, non-woven oriented carbon fibers encapsulated within that thermoplastic polymer. So what's very unique about this is, again, we are the only company in the world that actually developed a cone technology for our quote-unquote entry-level floor standing products. Now, when we start talking about the Core 826D, this is very unique. Now, I will tell you that we are not the first company in the world to have a speaker on top of our cabinets to create that Dolby Atmos effect. But what we are is that we are the first company to develop a patented waveguide to help us to improve this technology. So it is called the Augmented Directivity Speaker Technology. And the idea behind this is that on a traditional, Atmos enabled speaker is that we have a speaker that sits on top that fires towards the ceiling, and unfortunately it just disperses in that 360-degree pattern. With us is that we've paired it with the augmented directivity speaker technology, which actually allows us to almost focus or laser beam that energy to the ceiling, and only once as it hit the ceiling does it then disperse. And the advantage of this is that not only do we allow us to have a larger quote unquote sweet spot for the listening or better off access as listening, is that we can be as close as 3.5 feet from the speaker and still have the full Dolby Atmos um, um, experience. So where on a traditional, speaker, Dolby Atmos enabled speaker, is that at 3 feet you can literally hear that speaker is on top of the cabinet. With us is that at 3 feet the speaker or the sound is still coming from the ceiling of the room, of the listening room. So with that, again, we are certified by Dolby Atmos. The top chart there shows that we must remain within the red bar graphs. As you can see, is that we actually sit right around the middle of this gauntlet of frequency ranges. But more importantly is actually the bottom chart or bottom graph on the bottom right. Is across the top you can see a small faint red line coming down at a 30-degree angle, and the fact is that you must sit underneath this line to be certified. And there is a lot of other products out there that are certified, but on average they sit between 1 to 2 dB below this line. And our measurements is that we on average sit between 12 and 15 dB below this line. And the fact is that Dolby Atmos has actually never seen a speaker of this caliber or of this performance. And they were so impressed with this product is that they actually utilized this product at their booth at the last CES or CES 2020 and also at NAMM 2020 in Los Angeles for their demonstration purposes. And again, they are being so impressed with it is that we're actually in negotiations to actually outfit the Dolby Labs in the Bay Area with this product for their testing and developments and tuning and so on and so forth. So within the Core 800 line is that we have 3 finishes. We have our dark wood, our black, and our light wood. Dark wood consists of a turquoise gloss front finish with the dark wood cabinet. Black is a high gloss black face with a satin black cabinet, and the light wood is a gloss ivory face finished with the light wood cabinet. Now again, this is available in all models as well, including the center channel, but not the surround. The surround only comes in the satin black. Now, with it, as we mentioned, specifications, the 826D consists of the 25 millimeter aluminum magnesium inverted dome tweeter paired with the slate fiber 6.5-inch mid-range and dual 6.5-inch mid-bass drivers. Again, we do for the Atmos effect, we do have the 13 centimeter or 5-inch full range Dolby Atmos speaker up on top. Core 826 is again same specifications, same sound signature, except it is missing the Atmos speaker on the top. Core 816 includes again the same TNF 25 millimeter aluminum magnesium inverted dome tweeter paired with a 6.5-inch mid-range and a single 6.5-inch mid-bass driver. Our Core 806 is again our traditional 2-way bookshelf with the 6.5-inch mid-range with the TNF 25 millimeter aluminum magnesium inverted dome tweeter. And our center channel includes 2 6.5-inch mid-range with the TNF 25 millimeter aluminum magnesium tweeter. Our Core surround is consisting of a single 6.5-inch mid-range with a single TNF aluminum magnesium tweeter. On our subwoofer front is that we offer 2 subwoofers. We offer our Sub 1000F. This includes a Flax 12-inch subwoofer paired with a 1,000-watt bass amplifier. This is a sealed enclosure, but being very honest with you is that you would never know that this is a sealed subwoofer because of its performance. And our entry-level subwoofer is the Sub 600P. This is again using our Polyflex or polyglass cone technology in a 12-inch woofer paired with a 600-watt Class D amplifier and a bass reflex enclosure or a vented enclosure. Any questions on any of the classic products? Great, I'll take.
What are the what frequency are those getting down to? The subs.
The subs?
Yeah, what's the range?
Man, you're asking me the tough questions right now, but I believe it is like 28, 20, somewhere right around between 25 and 28 hertz.
Okay. Cool. Thank you.
So, but don't quote me on that. I have to go and actually.
Oh, I'm quoting you.
But that's my guess. All right, so let's start custom integration. All right, so within our custom integration range, we actually have 3 series. We have our 1000 series, which is our brand new series, our 300 series, and our 100 series. With this is that, as you can see, our top 2 models are made in France, our 1000 and our 300 series, and our 100 series is developed in our manufacturing facilities in China. So we will start quick overview of 1000 series. With it is that we actually have utilizing our top cone technologies. This is our W sandwich cone paired with the Beryllium inverted dome tweeter. Within the series, again, we have our 7 models. With this, again, utilizing these technologies. These price range anywhere from basically $1,100 each all the way up to $7,500 each. Now, we are going to focus on our 300 series today. Again, this has been our bread and butter. This has been very, very exciting over the last few years. So with this series is that we have a couple of different applications. We have our in-ceiling, in-wall applications. We have our in-ceiling application, and then again, we have our in-wall application. So within the series is that we are utilizing our flax sandwich cone technology paired with the aluminum magnesium inverted dome tweeter. With this is that all of this series includes the low profile frameless magnetic grills. They are, again, paint ready. We make them, we also have the acoustic liner available in these units. We actually include it in the box, but we actually don't install it on the grills because we understand that once you get up to an, to the mid to the higher series of products, there is a greater chance of it being color matched. So with this is that we allow it to be color matched, and then the acoustic liner can be added into the grill itself. We also include a magnetic paint shield in every single box. So every single speaker comes with a magnetic paint shield. Now, within the series, again, we have our in-ceiling, in-wall speakers. The idea behind this is that we wanted to create the most amount of applications, or have the most amount of applications with the least amount of models. So with this is that we have our ICW product, or in-ceiling, in-wall. This includes 3 models, a 300 ICW8, 300 ICW6, and our 300 ICW4. With this is on the 6 and the 8 is that we have the rotary as well as pivotable tweeters upwards of 20 degrees off axis, as well as that we have also the plus or minus 3 dB tweeter adjustments on all 3 models. Now within the series is that we also include the round and square grills. This comes in every single box. This allows us to not only have an option for either in-ceiling or in-wall applications, but also allows us to integrate into the interior decor of the installation, where maybe a round circle doesn't look good on a square grid, as an example. So probably what this series is best known for is our EQI system. This stands for Easy Quick Install, which means that ultimately that there is no tools required to install the speaker once the hole is cut. So the idea behind this is that we saw 3 major issues. The first one is that we saw damage where dog legs were being possibly, over torqued. We were popping drywall, screw guns through speakers, screw guns through drywall. So we really wanted to eliminate the damage side of the installation. Secondly was safety. Is the fact is that we saw guys standing on an 8-foot ladder with one hand on the speaker, holding it in the ceiling while trying to reach for the screw gun between his legs. And the fact is that we don't talk about it, but unfortunately there was a lot of a lot of injury because of trying to install speakers and so on like that. So again, we wanted to make a safer installation. And the third one was time. Is that we looked at the industry and found that on average it took between 8 and 10 minutes to install a single speaker. Where with the new EQI system is that the speaker itself can be installed anywhere between 2 seconds and 120 seconds for installation. So let's show you how to install them. So within every speaker, we have this QR code, and again, this will actually directs the technician directly back to this video if they have any questions for installation. Now we start with our support ring for the ICW products, and with this is that we have self-tensioning brackets that self-level and self-seal, and then we use a swing, slide, lock application for this ring, which means that it can also be easily removed in that reverse order. With that, again, we now have push terminals on the back of the speaker for quick and easy termination. And installation is as easy as now lining the arrows on the speaker to the unlock icons on the support ring. We place it into its location, and we literally just twist it into place to lock it. And as I mentioned earlier, installation is finished with the magnetic frameless low-profile grills. So again, very simple, very fast, or an EQI or easy, quick install. So moving on to our in-ceiling model. This is our 300 IC-LCR5. Again, with this product, we have multiple options to be. This can be either used as an audio-video application or in a stereo application. This is a true three-way speaker. Incorporates a 1-inch aluminum magnesium inverted dome tweeter paired with a 4-inch mid-range and dual 5-inch mid-bass drivers in a tuned vented enclosure. The housing itself is sealed, so again, it can be placed into a sealing location and not have to worry about insulation or anything getting into the enclosure itself. Now, this is a IC-LCR, so again, can be utilized as a left, center, right application. So we'll start with the installation of this unit. So on the back of the unit, again, we have the spring-loaded mechanisms. And with this is that we also include adapters. Now the adapters allow us to have an installation anywhere from 2.1 inches thick all the way down to 0.5 inch of a mounting surface. The extra adapters actually store or house onto the housing. And for installation, we literally just place it or push it into its location. And because it is an in-ceiling product, is that we do have the optional locks. And for that left and center right application is that pod moves plus or minus 30 degrees off axis. Last but not least is our in-wall products. We have two models. We have our 300 IW-LCR6, which is actually probably our most popular model in this series, and our 300 IW6. 300 IW6 is our traditional two-way 6.5-inch mid-range paired with the aluminum magnesium inverted dome tweeter. And our IW-LCR6 is a three-way. So again, 1-inch aluminum magnesium inverted dome tweeter paired with a 4-inch flax mid-range and dual 6.5-inch mid-bass drivers. With this, again, we do offer both tweeter and mid-range level adjustments. On the IW6, the tweeter will rotate and pivot upwards of 20 degrees off axis. And on the IW-LCR6, the mid and the tweet will rotate by 90 degrees. So again, with the installation, again, we have the spring-loaded tensioners onto the back. Again, we load these up. Again, push terminals for easy termination of our speaker wires. And installation is as literally as quick as placing it into its location. Again, level adjustments, and again, utilized in a horizontal position. 4 screws, we can pivot the midsection by 90 degrees. And again, finished off with that low profile magnetic grill. So any questions on 300 series? Wonderful. All right, we'll finish off by covering our 100 series. Again, this is our cost-effective series. So within this series is that we have our ICW, or in-ceiling in-wall applications, our in-ceiling applications, in-wall applications, in-wall subwoofer, and our outdoor products. So we'll start with the driver technology. So within this series is that we are pairing the polyglass cone technology. Again, as I mentioned earlier, this is our oldest cone technology that we own, and we have paired this with the aluminum inverted dome tweeter. The polyglass cone technology is actually a pressed pulp cone lined with glass microbeads. Again, the glass microbeads allow us to give us additional rigidity onto the pressed pulp without adding weight. So we'll start with the tweeter itself. So when we designed this series in 2018, we developed a new 25 millimeter aluminum inverted dome tweeter. With this is that we actually increased the excursion of the tweeter by 50% over its previous generation, allowing us to have a lower resonant frequency, allowing us to optimize coupling with the woofer itself and better phase alignment. As I mentioned, is that we've moved to the polyglass cone technology for the mid-range and mid-bass drivers. The advantage of this is, again, we have substantial performances over a polypropylene cone, which is what we would see in our competitors' products in this price category. The advantages, again, gives us better dampening, better rigidity, and also gives us the protection against humidity. So this product, or this series, would be utilized in applications like a bathroom, sauna, pool, and that application. Within the series is that we have also increased magnetic the magnet structures as well as excursions, allowing us to have a lot more output as well as a lot lower frequency resonances. Within this series, again, we also include the low-profile frameless magnetic grills. Again, these are paint-ready, and do include the acoustic liner already installed onto the grills themselves. So with this a new series came a new crossover, is the new optimized directivity crossover. So with this, the first idea with this is to remove the shower effect. So it gave us wider dispersions on the tweeters themselves in the mid ranges. So again, we don't have that hot spot as we walk around the room, or more homogeneous sound signature as we move around. Now, one of the key features is that we have also built in a thermal capacitor, so that if in such case that the 100 series speakers are overdriven, is that they will actually thermally protect themselves. At that point in time, once it cools, is that they will reset. The idea behind this is that we don't want you out doing a service call for a $149 speaker. So our in-ceiling in-wall, or our ICW products, includes 3 models. This is our 100 ICW8, our 100 ICW6, and our 100 ICW5. The tweeters themselves, again, are pivotal on the top 2 models, on the 8 and the 6. They will, again, rotate 360 degrees and pivot upwards of 20 degrees off axis. Again, the ICW5 does not, due to its actual profile. With this, again, all these models include both the round and the square grills in every single box. And these guys are have an 8 ohm minimum impedance, so which allows you to parallel wire these for multiple speakers within a room. We also have our IC6ST, or our stereo speaker. With this is, again, we are not the first company in the world to develop a stereo speaker, but we are the first company to install the acoustically optimized stereo flange. And this is actually a small wing that sits between the 2 tweeters. And by us doing this, gives us actually 2.5 dB of stereo separation. Now, with that wing paired with the ability that these tweeters can be rotated 360 degrees around, means that we can actually set a left and a right in, say, a bathroom or a hallway, as an example, with this single speaker. Now, we also do include the round and the square grill with this speaker. Moving on to one of my favorites in the series is our 100 IC-LCR5. Again, this is our in-ceiling left, center, right application. And so it does have the same footprint as the 300 IC-LCR5. Now, what's very unique about this is that this is a single 1-inch inverted or aluminum inverted ohm tweeter paired with dual 5-inch drivers and an 8-inch mid-bass drivers. Now, the fact is that with this is that it is a left, center, right. So as we designate it, or if such case that we say place the speaker up in the front left-hand corner of the room, is that we now go to our mode switch. We switch it to a left, or tell it that it is a left speaker. And by doing so, it actually attenuates the right 5-inch driver by 6 dB, allowing the speaker to become more directive from the left-hand side. Same thing if we move it to the right, it will then attenuate the left-hand driver by 6 dB. Or most importantly, as we use this as a center channel, is it will play both 5-inch drivers equally, giving us again that more powerful output for things like sound effects and dialogue that we require out of a center channel. Last but not least is our in-wall speakers. This is, again, two models, our 100 IW6, or traditional two-way, 6.5-inch with the aluminum inverted ohm tweeter, and our 100 IW LCR5. Again, this is set as a D'Appolito application. Can be either utilized in a horizontal or vertical application. On both these models, the tweeters are rotatable as well as pivotable upwards of 20 degrees off axis. Again, we do also give you mid-range and tweeter level adjustments on both of these models. On our in-wall subwoofer, we have our 100 IW Sub 8. This is a pre-construction subwoofer application only. It is a 8-inch polyflex or polyglass driver paired with a bass reflex tuned enclosure. The enclosure itself is designed to sit within a 16-inch on center stud bank. With this is that we also include all of the accessories for installation. We include the drywall beauty ring. We include the magnetic frameless low-profile grill. We include the mounting brackets, isolation tape, and even include the mounting screws or hardware. To run this subwoofer is that we have our 100 IW Sub 8 amplifier. This is measured at 1U. It is also at 19 inches wide, so it does allow us to be rack mountable. We do include the rack mount brackets, as well as also the feet for a furniture application. This unit is rated at 150 watts at 8 ohms, but this unit is also 4 ohm stable, which means that we can now run 2 of the 100 IW Sub 8 enclosures off of a single amplifier. On the front of the unit is that we have our variable adjustments, including level, phase, crossover, as well as the auto on feature. On the back side, again, we have our traditional speaker terminals, as well as we have our RCA left and right, as well as LFE input, as well as a left and right output, allowing us to actually daisy chain multiples of these amplifiers together. Within the protection circuits, again, we've added the dynamic power control, short circuit, fuse, thermal, and overcurrent applications. Now, with these two models, that we have a multitude of options to purchase. Is that you can purchase the amplifier on its own, the subwoofer on its own. You can purchase one subwoofer and one amplifier as a package, or you can purchase 2 subwoofers and a single amplifier as a package. Rounding out the 100 series is our 2 outdoor speakers. This includes our 100 OD6 and our 100 OD8. This is a 6.5-inch and 1-inch tweeter, or 8-inch and 1-inch tweeter. Again, utilizing the polyglass cone technologies with the aluminum inverted ohm tweeter. These units are available in either black or white. They are also paint ready, which means that they can be color coded to the exterior decor or to the interior decor, however they may be used. One of the major advantages of these units, as we take all the stainless hardware, powder-coated aluminum brackets, is that these units are also IP66 certified, which means that they are extreme weather rated, as well as that they will take direct water. So these are very cost-effective, I believe, sitting at $299 each retail for the OD6 and $349 for the 100 OD8. So with that is that we also have our accessories for our CI line. We have our pre-construction brackets. We have made it very easy for you to order the pre-construction brackets themselves. Is that we have ultimately taken the model number that the bracket works for and added the word mount to the end of it. So if in such case that we wanted to install a 300 ICW8, the bracket for it would be a 300 ICW8 mount. So again, made it very simple to order and available for every single model that we have. Additionally, is that we also have our fire rated back enclosures. So with these is that these are UL 236 fire rated, and allows you to be utilized in instances or residential instances where you require a fire rated back enclosure, or in a commercial application where again it's requested. But there is also an additional feature to this, is that we actually get close to 20 dB of attenuation off the back wave of the speakers. Again, this can be utilized for in cases where you're using a multi-floor dwelling or a multi-dwelling of complex, as an example, where you don't want to have that back wave transfer into another room. The last thing I want to talk about is coherent alignment. Is that because we utilize the same technologies between our CI and our floor standing products, is that we have coherent alignments. And so we find in a lot of cases we have clients that want to do those, those statement floor standing products, whether it be, Kanta, Aria, Utopia, whatever it may be, and then possibly build a theater system around it. So in this case here, our 1000 series is coherently aligned with our Utopia and our Sopra product. Our 300 series, again, utilizing the same cone technologies of the flax and the aluminum magnesiums, are coherently aligned with the Kanta and the Aria 900 series. And our 100 series is coherently aligned with our Core 800 series. And with that, I thank you for your time.
Well, thank you, Chris. Appreciate it very much. And as Chris said, the lineup that he discussed here today is all available at 21st Century, and you can feel free to ask any of our sales associates for any help that you may have in designing your system, or what might fit the project best. And if you didn't get enough of Chris and I today, we'll be back here tomorrow. So with that, Chris, thank you, buddy. Appreciate it.
Awesome. Well, thank you for your time today, guys. Really appreciate it. And yeah, we'll same time, same place tomorrow.
Thanks, bud.
Awesome.
Thanks, everybody.
Great day,
Bye-bye.
guys.